Greetings, happy coders. Welcome to another video. And today we're going to be looking at none other than Set Willy, or Set King Willy, as some of you may describe it. And I am going to resist the temptation to make any kind of knob joke. We have had 40 years of very silly Willy jokes. There ain't going to be any in this video. So, let's talk about Set Willy and this little mod that I came up with over the weekend, which is to remove the death loop, which is of course the bane of many a player. Although there are those who argue that it's a bug. It's not a bug, it's a feature. Well, of course, that's your personal choice. Some people like the jeopardy. I think it's a little bit unfair. A little bit too much. You know, make a mistake, lose a life. Okay, make a mistake, end the game instantly. I think it's a bit too much. But anyway, if you want to be hardcore, you can be, because you know, the original is still there for you to play, and so you know, you do you. I just thought it'd be fun to do this. It might allow a few people to explore the rooms a little bit more, appreciate the work a little bit more, without having to spend endless hours and hours and hours that the purists have done, who perhaps want to maintain the game exactly as it is. But anyway, this game has been modded to high heaven, hasn't it? And you know, one extra little mod, it's not going to do any harm. So let's see. I'm going to explain what this is, and I'm also, for the benefit of those who are not so familiar with coding, then I am going to also explain a little bit about what we do when we want to make a mod like this, how it works, and so on. Right? So let's take a look at the problem. Here I am. I have made my way to the east wall base. I'm feeling quite pleased with myself. And I still have, what is it, 5 lives left? Yeah. And then, you know, just by accident, I accidentally fell off here. What would happen? Well, that would be the end of that. So that's really not ideal, is it? So, let's jump back to where we were. The power of emulation. Okay, we're back. We're saved. Okay. Let's turn the music off. Okay, so let's talk about what happens here. So essentially, when you're moving from one room to the next, the game records various little attributes, or you know, statistics, data about Willy, which is basically his X position and his Y position on screen. Is the pause there is just kicking in, isn't it? I think we'll just... Oop. That's better. Okay. So his X position, Y position, which direction he's facing, is he moving left or right, is he in the air or not, that kind of thing. And when you move from one screen to the next, what happens essentially is that... let's see if I can make this work for you guys. Right, so I'm here, and as soon as I go past this point here, the game recognizes that I have gone outside of the navigable area, so to speak, and that I'm moving downwards. It looks up which room is defined to be the next room, switches to that room, loads that room in, then resets Willy's position, but all it actually does is just moves him from the bottom of the screen to the top, right? So let's see if we can do that. Just a minute. Okay, there we go. So here you can see that the room has been drawn. The colors haven't been drawn yet, but essentially there he is, and he's been moved straight up, and now he's in Ballroom East. As I said, I've paused it there just mid as the room's being drawn, right? So what will happen is, well, what I think has actually already happened, judging by the colors, the game will detect if Willy has hit anything, and in this case, he has hit the barrel, which is there, not visible, but visible in memory, so to speak. And so he dies, and then as soon as he dies, the code will reset his life, take away a life, reset, and put him in the same position as he entered the room, right? So if you were down at the bottom here and you were moving across and you died, then you would just be reset to where you came in and you'd be safe. But if you enter a room in such a situation as this where you will die, then the game will loop, and it will make you do the same thing over and over again until all your lives are gone, which is exactly what happens here. Okay, so that's the end of that. Now, so what do we do about this? How do we solve this problem? Well, there are two things that we need to do to solve this problem. The first is that we need to know a position from which Willy is safe, let's say, right? A safe position which we can reset him back to, so that instead of resetting him to the point of entry, we reset him to the point at which he was last safe. So if you look at that from here, you can probably calculate and understand that the next position that he would be safe would be something like this. Right? That's the last time that he's in a safe position. As soon as I move a step further, he's going to start falling. And once you're falling, there's no control, right? So that brings us to the first thing that we can say is, if Willy is in the air or falling, we don't have control over him. And that means, of course, he's not safe. So if he's falling or in the air, he's not safe. That's the first thing. Right. Now, the next thing that we need to ask is he on a conveyor belt, right? Because again, if you're on a conveyor belt and you're moving, the player's no longer in control. I mean, they're in partial control because they can jump, but they're not in full control. So we should assign that as also not being safe. And in fact, in the room above, a couple of floors above this, I think it might be one floor above, not sure. I'm a little loath to try, and perhaps I will try, but the floor above this one, I'm not going to show off my skills very well here, but the floor above this one is, I think there's like a sort of sliding, let's see if I can just, oof, just made it, yeah, good, okay. So you see this thing here, that's the slide, and it's also a conveyor. So obviously the intention here, Matthew Smith's intention, is for you to, if you fall on this, you slip, you fall, the whole game is over. Yeah, that's a big jeopardy. But obviously what we can't do is have him, if we want to, go easy on the player. This pause thing is winding me up. Anyway, if we want to, we need to also check if he's on a conveyor. And if he's on a conveyor, then that's also not safe, right? Okay, and then the final thing that we should check as well, and this was done through testing, but essentially, if he is at this point and he is moving, then essentially the game will be one step ahead of us, and he will have moved into the next space, and he'll fall, and then he will get spawned in a position where he'll fall, and obviously that will also be game over. Okay, so let's now look at the second thing that we need to do. So that's the first thing. Where is he safe? And once we know where he's safe, we can record that. We can record his position, the room that he's in, the direction he's facing, the frame that he's in, and so on, right? We can record that so that if you then die, we can, instead of restoring him to his entry position, we can restore him to his safe position, right? So pretty straightforward. The second thing we need to know is how can we detect a death loop, right? How does that actually work? So if you think about what happens with a death loop, obviously what you're doing is you're entering a room and you are never safe in that room, right? So you never hit a safe point, you never land, whatever it might be, you die. So you're falling and you die, or you hit an enemy and you die. So therefore, if we are constantly updating Willy's safe position and safe room, then if he dies in a room which is not the room where he was safe, that's a death loop, right? Because it means he's gone into a room and has never found safety. So we can assume, therefore, that that is a death loop. And so those are the two things that we need to do. Step 1, record his safe position. Step 2, look for the signature of a death loop and when he dies, right? So if he dies and it's not a death loop, then it just does what it would always do, just reset him to his entry point. But if he dies in a death loop, i.e. he dies in a room where he was never safe, then we will restore him to his original position, right? Now, I've already made this into this whole thing into a downloadable, but what I'd like to do is to create a series of pokes, because it's not going to be a big amount of code, probably 200-300 bytes. And the advantages of using a poke file would be that you can apply it to any version of the game. So if someone has made a mod, you know, and there are hundreds of those, so this would be applicable to almost all of them, I would think, depending on where we choose to put the code, but we'll come to that in a minute. And secondly, of course, you can distribute it without any sort of copyright claim or anything like that too, right? I mean, obviously this is not something I'd be charging for anyway, but if for some reason that was the case, then obviously I'm only going to be releasing the specific code that I've written, so I wouldn't be distributing the original code or anything like that. So that would be another reason to do it. That does make it a little bit more complicated though, because what we need to do in order for it to work with a poke is we need to find a place in memory which we can use to essentially put our little bit of code, which won't disrupt anything in the game. And we also need to make sure that that doesn't move or overwrite or change anything else within the game. So for example, you know, if you might add a bit of code, if you were working with a disassembly, then it would get moved down memory, right? And then the position in memory of everything would get shifted. And obviously, if you do that, then you can't apply it to any other versions of the game because it wouldn't be in sync, so to speak. So you could call that a kind of memory sync, if you like. You need to make sure that all the rest of the game is identical to the original, so that when you apply a patch, it only kicks in at that point, right? So yeah, now it just so happens there is a sort of 200 or 300 bytes of code that we don't need for the game, really. Just give me a second. Is that gonna work? No, not that one. Just a minute. Probably this one, right? Oh, also a test. So essentially, I'll just skip the formalities and say that at the start of the game, as you will know, there is a copy protection system, right? And that copy protection system, which this one? Yeah, there you go. Finally found it. Good. So this copy protection system was there. I mean, I don't really need to go into too much here. There was a little code sheet. You had to get the numbers correct, and then that would give you access to the game, right? It's about 200 or 300 bytes of code, and obviously we don't really need that anymore. So yeah, what we're going to do is we're going to put our new modded code for preventing a death loop into that area, and then we're going to redirect the code to jump into our code and then jump back to the regular game, so that we don't mess up any other part of the memory, right? So yeah, I don't know if I remember this code. I suspect I do. Nope, I don't remember it. I think it's red, blue, red, green. We'll find out if I'm right in a second. Let's try red, blue, red, green. Hey! Obviously, it's always the same, isn't it? Because I've compiled it that way. So, anyway, that's that, right? And then what we'd be able to do with the POC file, if those of you don't know what that is, I think it goes back to the original multiface, and it's essentially a text file with a list of addresses and a list of values, and it will just, many emulators support it, including this one, Spectaculator, that I'm using. Fuse supports it. I think the Spectrum Next supports it as well. So you just open that file and it will poke memory, the addresses to memory of the changes that you want to make, right? So normally used for simple changes like infinite lives, but you can in fact create patches with it, as I did with Jetpack RX in fact. So it's like a whole string of memory changes that can be applied and make the game change slightly, right? So anyway, that's that. Let's switch over and take a look at how we actually make this magic happen, so to speak. So we'll bring this in. Here we go. This is Notepad++, and obviously here I am with editing. Let me just get my bald head back in shot there. You don't want to miss that, do you? Anyway, so this is a full source code and disassembly of Set Willy, and this is done by Richard Diamond. So I don't know if you're watching, Richard, but thank you very much. And if I assemble this, I've called it Set Willy Clean here. This is a completely raw, regular version, which is the one that we just saw loaded, of the game, right? And you can see there's all kinds of different things in here. I won't go into too much detail, but you've got things like music here, and you've got this right type of thing. You might remember this thing where you can type certain letters and it will transport you to a particular room, which I imagine was a bug fixing type thing. Yeah, and various flags, and then, I mean, again, I'm not going to go over this too much, but the further down here at the bottom is all of the rooms and the data. That's the vast majority of the game is mostly just data for the different rooms and what happens in them, which guardians are in them, and all that stuff. This is the stuff that people edit when they make their own versions. I'm not touching any of that either at the moment, just right. So, and for those who know the Spectrum memory a bit better, you can see this starts at 32765. Below that, in the lower part of memory, the game uses some buffers, sort of screen buffers. So that's why it's nothing below that point. Okay, so what are we going to do? Let's take a look. I think I saw it just earlier. You can see here is enter codes, right? So this is when the game begins. It goes straight into the enter codes, and this is the part which clears the screen and shows the code screen here. And JPZ means jump to the title screen, and that means if you got the code correct. And if you didn't get it correct, it will go back and you have to try again. And there would be some kind of a counter of how many times you tried, and then JP0 would be obviously jump to the start of memory, which would be a reset. So that's how all that works. And you can see here's the code, right? We're not going to worry too much about it. But you've got code screen, print the message, check the numbers, and it's all kind of in here. Now if I go to the memory map here, let's take a look at that, right? Okay, there it is. So you can see here that it's at 86C3, right? And this is the memory, and it goes down to here, checking. And then after it's finished, you can see the next thing is title screen. That's a new routine, 87CA, right? So that gives us an idea of how much space, because we're going to bypass that completely, right? Instead of calling code screen, we're just going to go straight to the title screen, right? We're just going to skip it. But obviously we'll then have a certain amount of memory which we can use to add our mod, right? So just to give us an idea, you can see that 87CA is the address of title screen there, and then if I go up to here, yeah, we'll keep that the same because that's that clears the screen anyway. But if I go to here, this is code screen, right? And well, we'll probably use this as well. But let's say we start from here, 86C3. So 87CA minus 86C3 would tell us how much memory that routine uses, right? And it's about 263 bytes, it says. So that should be enough for us to put our routine in. Okay, so if we look at the mod here, okay, and we go to code screen, just a minute. Just a minute. I'm trying to find the code, but the search, you know what's wrong with the search? Have I done something? Well, I'm sure I can just find it by scrolling down, so let's have a look. Okay, so here you can see originally we had call code screen, right? And instead of call code screen, I have got JP title screen, which is what happens if you get the code correct, right? And this JP title screen is the same number of bytes as call code screen, so we'll keep that in there. And what I've done is, this is the code, we'll look at it in a minute, but what I've done is I've done an org. You'll remember 87CA, this is where the title screen was if you look at the original. Right, 87CA, display the title screen there. So the reason that's there is that I can then clear this area here, and then if there are any blank spaces or anything left over at the end, it will just be filled with zeros. And title screen will be in the same position as it was, and then the rest of the game below that will also be in exactly the same position in memory. So we won't disturb anything in memory as long as we just work within this area, right? So that's basically that. Okay, so the next thing we ask is then what do we do with this safe check? When do we run it? Okay, and there's a main loop that runs, and here you can see this is where I run it. So this is the main loop of the game, and it does a few different things. Here you can see, look, main loop, right? It draws the lives, it moves things, it moves Willy, it checks a few various things to do with the game, and just before it does the check, rather than drawing the items, what I'm doing is calling the safe check at this point. So I'm basically replacing the call to draw the items with a call for the safety check. So it's just an entry point, really, and I know that this will use the same amount of bytes as this, so none of this will move either, right? And that's important, as I said. If you're going to make a patch, then you want to keep the rest of the memory the same. Okay, so if I go back to the safe check, you'll see that what happens at the end of safe check here is it jumps to draw items, right? So in other words, what we're actually doing, instead of calling draw items, we're calling safe check. When safe check is finished, it jumps to draw items, and when draw items is finished, it will return, and it will return to this point, or if it's been called, where it's been called from, it will return. So it will effectively, what we've done is created a safety check that runs, and which is then followed by draw items, which therefore makes the game run exactly as it would have done without this safety check, right? And that will run every cycle after these other bits have been done here. Okay. So let's take a look. What exactly do we do? Well, first of all, got a little bit of commented out here. This was a border. I was just playing about with the border. The border is a good way to test things in the game. So I originally had it so that it was blue when he was safe and red when he was in danger, something like this. Maybe the other way around. So let's take a look at what we actually do here. You can see, first of all, we have, is he airborne, right? I'm not sure what this is. I might remember in a minute, but anyway, is he airborne, right? And if he is airborne, then he's not safe, right? So the air check done, JP draw items done. Nothing's going to change. No update to the safety position if he is airborne, right? Now we look at his direction. Is he moving? And if he's not moving, we'll check for a conveyor. Here we check for the conveyor. Here it is. Now the conveyor is a little more complicated. It starts with his location. It adds 64 because it looks 2 steps below. If you imagine his head, plus 32, plus 32. So it's just below his feet. And we see if there's a conveyor there. And then we go across one space and see if there's a conveyor there. Now, what I found was that additional to that, sometimes, especially when he's on that slidey thing, when you exit the conveyor, it is possible that excuse me, it is possible when you exit that there is a conveyor there, but it's not detected by my first 2 checks. So what I do is I go back up 2 spaces and just behind him, and if there's a conveyor there, he's also not safe. And what I found was that was enough to detect him when he's on a sort of slidey ramp or something like that. So that's what that is. Okay. And here, if we've got the, I don't think that load C one actually does anything, to be honest. It's probably a redundant code that was used before. Oh, maybe not. There's another thing here, so maybe perhaps we'll find out in a minute what it does, because I don't remember. Anyway, back to this. He's not airborne, is he? But he is moving, right? So if he's moving, we need to check which direction is he moving in, right? So, and I've got B here as a 0 and B here as a 3. And now the reason for that is that Willy has 4 frames, 0, 1, 2, and 3. And if he's facing one direction, then his last frame before he falls off a platform will be 0, and in the other direction it will be 3. And so if Willy is moving and he's on his last frame, then he's not safe, right? So that's essentially what that does. And we need to know direction. So here, if he's moving one direction, check frame 0. If he's moving the other direction, check frame 3. You can see here, compare with B, and if it does match, then that means that he's not safe, so don't store it. Okay, and there's the conveyor check, which we already covered, and that is pretty much it. So what we then do is we say, okay, he is actually safe. We go to his I'll show you this anyway, right? So just a minute. We go to his little attributes, his little data set here, which is just a minute. That's probably mentioned all over the place. But you can find that. There you go. Right. So you can see it's very well annotated by the original guy who disassembled it, and you can see you've got here, you've got Willy's pixel position, you've got his what direction is he moving in, is he airborne, what frame is he, what's his location on screen in terms of the attributes, which is also his X coordinate, and a few other bits like that, right? So if we go back to where we were here, right? So we just basically store, I created an additional bit of space here called Willy safe state, and I've got the 7 variables here, and I just copy those from Willy's current position and current data into there. So we back up his safe position, that's what that does there, and then we back up the room that he's in, and we've got another thing here called safe room, right? Just like that. Okay, and yeah, I think that's it. Okay, right, now we know what the border is. Okay, finally I realized. Okay, so the border, we know what C is, right? So C was basically the border check that I mentioned, right? So it's blue, and if he is safe, it is changed to red, and you can see there I would have set the border up and it would tell me. So that was what I was using to test it. So we don't actually need that anymore, but it doesn't matter. The memory, we've got enough memory, so we don't need to worry. And if I do need to go back and check it, then I can just re-enable this border check. So that's what that was. Of course, I should have realized. Okay, so that's that first part. That's where we are storing his safe position. Okay. So the second part is, of course, the what happens when Willy actually dies, right? So let's see where that is called. It's just over here, right? So in this part of the code here, we've got lose life, right? And if Willy loses a life and it's not the last life, then the game is going to continue. And ordinarily, at this point, the game would check if there is any lives left. It actually copies, you see here, in its state, right? This is the thing that causes the problem, because it copies Willy's initialization for the room back into the position and resets him, right? We'll leave that for now because we don't want to mess about and change the code here because of the memory structure. Instead, rather than jump to init room, we are now going to jump to init room dead, which is a new routine, which is here, which is stored just above safety check, right? You probably noticed it if you had your BDI. But here, Willy died. Check if he died before being safe. Now let's just double check what happens at the end of this. It jumps to init room, right? Same principle as the previous one, in which we jumped back into the regular code, right? So all we're doing is it's like a sort of hijack, if you like. You just basically divert the code and then bring it back in again, so nothing is interrupted. And let's take a look at what we actually do here. We look at the safe room, we compare it to the current room, and if it is the same, then it means that he died in a way that wasn't a death loop. You remember I said if it's different, then it's a death loop. So if it's the same, just go back and continue, right? So it doesn't need to worry about putting him safe, because the player just died in an ordinary way. Okay, now here, but if that doesn't happen, it means that he died as soon as he entered the room. So we take the safe room and we make that the current room, and then we get the safe state and we copy it over to the current state, if you like, and we then reset the Willy's movement flag just to make sure he's not moving, just to keep him extra safe, and then we jump to the init room, and that is pretty much it. In fact, you can see there, that is it. That's all of the code. So yeah, that's that. Now, what we then do then, so we assemble that, obviously, and we can see that it's assembled over here, and we can also double check. So, like for example, it's always good to just double check these kind of things. So we can see that the only thing that will have changed is the area where the code entry system is, right? So, you know, if I look at, for example, I'll just move down a little bit outside of there. So, for example, if I look at 8871 on here, right? And this is in the modded version. And then if we look on here, you can see, let's just check, there's 8871, 8871, load AE, and there is the same, right? Title screen 4. Let's see if I can just do that. Just want to show you that essentially that what we've done here is set it up so that the memory there, right? So if I just compare those two, for example, you see, although the line numbers are different, the actual memory is exactly the same. All the code is the same, and that'll be true right throughout the code. Okay. So yeah, if we now run the modded version of this, which is a tap file for now, Set Willy safe mod it's called. Well, let's go over to that and see. Right, so just a minute. Take that away. We'll go back to the game. And we'll load that in. Okay. So the first thing that you'll notice there then is that there was no code entry anymore, right? So, and obviously the reason for that is that our code has replaced the code entry system. And the other thing is the code entry system is quite high up in the memory, sorry, quite low in the memory, which means that the rest of the engine will be the same. So if there is a mod of any kind, then that will be, it won't disturb it, and so it should work with almost any version. Okay, so I'm just going to try and head up here to where things are not safe. I'm not crazy about this though, but I think I might be alright. I might have managed it. Let's see. Are we going to make it? No! Dagnammit. Okay, should be alright. Just a little bit better timing. There we go. Right, so if I die now, Hey, look, we're there. That's our save point, right? Now, one of the issues that could happen, is he could respawn at a place where an enemy actually exists, right? But I've done some testing, and that doesn't really seem to happen unless you really, really want it to happen. So, you know, I could fall off here, for example. And yes, I could have been got by that, but I managed to just dodge it in time. So that can happen, possibly. But obviously, the main thing is just when you make a big mistake and fall off somewhere like that. And that's when the code kicks in. Right. So that's pretty much explains all of that stuff. Now, the other thing that I do with this, and I don't actually have it to show you right now, so I'll just have to explain. But my good friend David Sapphire, hi David, if you're watching, he made a little application for me, which allows me to compare the memory of you know, two snapshots, right? So what we do is we start the game, go to the main menu, and we take a snapshot. That's the original clean game, and then we take the modded one and we take a snapshot, and then we just compare. We do like a diff thing, like a difference, look at the differences. And obviously there'll be a few little differences in terms of timings and everything, but when we look at the area of memory that we've changed, then we can see all the differences in terms of the changes that have been made, and it creates auto creates a POC file. So excuse me. Now that I can show you. So this is what the POC files look like. This first part you can just ignore because it's just that just means the regular memory bank 48K. And this is the address, this is the original, and this is the poked value. So you can see these are the changes that were made, and they're all in that sort of ballpark area. So the only things that changed are the code entry system, and then there's a couple of redirects, right? You remember the jumps that we made. So there's a couple of things like this. Now I've actually, in this one, I've also added original fixes, which are optional, which are the bug fixes in the game, which software projects provided when they realized that the game was buggy and incompletable. So that makes a couple of items visible, collectible, something like this, and stops an arrow from disrupting the code, and a few bits like that. So those are easily available and downloadable for anyone who wants to apply them. But I thought, you know, for the sake of convenience, might as well add it as well, right? So yeah, there you go. That's pretty much how it works. Hope you found that interesting. And you know, do let me know in the comments if you've tried it out and what you thought. And yeah, I think we'll knock it on the head there. It's been an interesting one, and no editing required, so that's always good. Okay guys, I will see you next time, and as always, happy coding. Bye bye.